coding interview questions can be super stressful, unless you're ready for them. This is a video I did a few years back dissecting the most ridiculous and basic interview question that you could be asked, Fibonacci. But wait, before you click away, please wait. There's a reason that even the most seasoned pro developers out there are asked super basic questions like this one. Aside from knowing your stuff, they want to see how well you understand the underlying concepts and how well you can explain them. This video is not about solving Fibonacci, rather how you talk about it. I pulled it from the Coding Interview Bootcamp course that you can find up on my blog at robconnery.com, where I have a lot more videos just like this one. All right, enough of that. Off we go. Hope you enjoy.
So let's start with the obvious. Do you know what Fibonacci is? That is the very first test in this question. If you put on your resume that you have a CS degree and you don't know what a Fibonacci sequence is, your interviewer might get suspicious about you. This is one of the very first algorithms that you learn when learning about algorithms. Now, as a self-taught programmer, I learned Fibonacci and promptly forgot it many times, and this is okay. You can be honest about this in your interview. It's okay if you don't remember what Fibonacci is. Just ask them. They'll likely help you out. Now, if you're one of those people that doesn't know Fibonacci, that's okay. A Fibonacci sequence is a set of numbers. Each number that's greater than 1 is the sum of the previous two numbers. The ratio between these numbers is 1.618 and other numbers, and that's phi, the golden ratio. Now, all you need to know to solve Fibonacci is the algorithm, a sequence of numbers, each of which is the sum of the previous two. Your interviewer will most likely ask the question in one of two ways. Return a Fibonacci sequence to the nth position, or return the nth Fibonacci number. Now, in our example here, 21 would be the 9th Fibonacci number. Now we get to the chess match. Can you solve this problem in a simple way? If you've been to a coding interview before and been asked this question, study up on common problems and so on, then likely, yes, you can answer Fibonacci. Let's take a look at one of the simplest solutions that you could write. Now here I'm using standard JavaScript, nothing tricky. I have a check that returns n if n is less than 2. Otherwise, I fill an array with Fibonacci numbers and return it. This is a pretty standard answer to this problem. But wait, did our interviewer ask for a sequence back or just the nth number? Were you listening? The interviewer will be looking out for this. And if you jump right in and solve it without asking what the return is, it looks bad. Again, this is part of this problem. Are you going to just jump in because you know the solution and I've got this, here we go, boom. And just make sure you slow down and listen. Okay, just in case, here's what we could do to return the nth Fibonacci number. Now comes the fun part. Your interviewer will be asking you questions during this time. Sometimes these questions are helpful. Why are you using an array here? And sometimes they just want to know if you can describe your code to a deeper level. First, what do they even mean by describe the algorithm to me? One answer might be, we have a loop, and here's an array, and I'm returning the last element. Nice work, Captain Obvious. If an interviewer says, describe your algorithm to me, they typically mean things like time and space complexity, and also algorithmy things like dynamic programming and memoization. So let's try that again. Overall, the process that we're using here is called dynamic programming. Not in the Ruby or JavaScript typing sense. This is a way to solve an algorithm by dividing it into smaller problems and using something called memoization. In other words, caching to speed things up. So we have memoization here with our fibs array. We're just remembering the last two elements in a sequence. We have a single for loop, which means that our time complexity is order n, and we're also building an array, which means that our space complexity is order n as well. Being able to describe these things is a major part of why interviewers like to ask questions like Fibonacci. If you're able to do that, your interviewer might ask you to improve on the space complexity, to squeeze out the most efficient algorithm that we can get. This is a good thing, as they want to see what else you can do with this algorithm that you've written. Now, this is a tricky algorithm if you don't already know it and are trying to figure it out right there on the spot. To get to order 1 space, we need to stop using an array, which is what is causing our order n space. If all we use are variables, we're good. So we can move away from dynamic programming and use what's called a greedy algorithm. In other words, it does its calculations based solely on what's near it at the time, which in this case is just 2 other variables called twice and last. So let's plug it in. We just need to add 2 variables to remember the last 2 Fibonacci numbers and 1 to remember the current. I'll call those twice, last, and current, and I'll initialize them to the first 2 Fibonacci numbers. Next comes the tricky part. I need to reset these variables in the loop so they remember the values that we need to remember. I start by setting the current Fibonacci variable as we know how. It's the sum of the previous two. Then I reset these variables as we're incrementing up the sequence. 2 Fibonaccis ago become the last one, and the last one becomes the current one. Also, notice that I'm starting the loop at the number 2 here. And this is because the first 2 Fibonacci numbers are known already. So we start the loop there. So let's step through this, and I'll try to make it as visual as possible. Notice that I have a Fibonacci sequence at the top there, and I've colored in the current values for twice and last so we can keep track. Also, those values are represented literally in the code in the same color. We'll start with n equal to 10. We'll pass over the if statement, and we set current equal to twice plus last, which is 0 plus 1. Set twice to last, which is just 1, and finally set last to current, which is also 1. Now I equals 9. Current will get set to 1 plus 1, which is twice plus last. Twice is set to last, which is just 1, and last becomes the value of current, which is just 2. Now I equals 8. Current gets set to 1 plus 2, twice to 2, and last to 3. Okay, just one more time. I equals 7. Current gets set to 2 plus 3. Is this boring you? You should try reading it. It's not exactly the funnest thing to do. Why am I doing this? Why am I pressing through this? Because this is important. The ability to step through your code like this and to build out a solution with some test data, you're going to have to master this. So if you're patient with me speaking it to you, then maybe you're going to be patient with yourself as you check your code. Sorry to put you through all that. Okay, so let's just stop here. We'll just say, ta-da, I know this works. I think you probably know this works by now. And yeah, we're good to go. Or are we? Our interviewer just threw us a bit of a curveball. They might want to push you a bit. If you've solved this already, they might want to see what else you can do here as a coder. Maybe they want to see if you can do this recursively. Quite a few developers won't know how to do this recursively, believe it or not. Do you know how to do it recursively? Fibonacci is a beguiling little problem. There are so many ways to answer it. If you're asked to solve it recursively, it's probably because your interviewer wants to see just how good you are. Do you really know recursion? You might know the solution from reading it online, but is it safe to just throw it on the board as if it's super simple? Well, let's see. In this example, I'm just going for it. I've read a book and I've seen some code online that discusses lambdas and Fibonacci, and I remember this one-line lambda, so I think I'm going to try to impress the interviewer and strut around the room for a little bit. I feel pretty confident in my ES6 skills as well. So this solution works, and despite looking a little bit cryptic, it's actually pretty elegant. The interviewer does look pleased, but is wondering if you really understand the algorithm that you have created here. You could respond with, well, I can see why a junior developer might not understand some of the syntax. Lambdas are pretty new in the JavaScript world too. Ternary statements have been around, but blah, 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 blah. Oh my gosh, you sound like a windbag. Nice work. You've just told the interviewer something that they might have been pondering. This person knows some code, but do they actually know what's going on behind the scenes? If you're going for a job at a big company, this question could weed you out. It's important to them that you know what your code is going to do as it scales. The code that you've just written is probably the worst answer that you could have given to this question in terms of complexity. It is elegant, though, so nice work there. The interviewer wanted to know if you knew why. So let's have a look. Our first function call is going to branch off into 2 more function calls, which will branch off into 4 total function calls, which then turn into 8. We've seen this structure before, haven't we? This is a binary tree. Maybe you've seen this using divide and conquer to find something using binary search. Now, it might be tempting to look at this and think, so this is a logarithmic operation, so it would be order log n or something? Well, it might seem that way, but this is what they're going to want to test you on. We're doing 2 operations per split. So looking at this graph, we can count up 1 plus 2 plus 4 plus 8 plus 16, 32, 64, 128, 256, 512, 1024. 1,024 operations total for only 10 inputs. In this sense, yes, logarithms are helpful as they tell us that 10 is the exponent that describes what's going on here. In other words, log base 2 of 1024 equals 10. And if you remember your logarithms, that means that 2 to the 10th power equals 1024. So given that n equals 10, And we can then derive the actual complexity of our algorithm, which is order 2 to the n. Ouch. This is exponential complexity, and if you want to see how bad that is, run the code that you see here and search for the Fibonacci number at the, let's say, 1000th position. Okay, don't do that. Don't do that. It'll peg your CPU. So in short, this code is a disaster, and your interviewer might be hoping that you'd recognize that fact. All right, well, maybe you did. Congratulations, that's rad. Good for you. Maybe you've recognized that a recursive Fibonacci can be destructive, and you are able to demonstrate that to the interviewer. And now they follow that up with, okay, well, how would you fix the complexity problem that you're having here, but still use recursion? This is tricky. Well, I didn't know the answer to this question until a few months ago, to be honest. I would have just said, I don't think it's possible. And you might be forgiven if you said the same thing. But there is a way, and it's lovely. The problem that we're having with this code is that every call has to wait for the result of every ensuing recursive call. This means that stack space is allotted for each call, which is bad. Moreover, we have to make the call many times. What if we changed it, though, so that we don't have to wait and we can use a running sum instead? Well, here's a way to solve Fibonacci recursively, but with a technique called tail recursion. You simply pass along an accumulator and set it as you need to. Now, again, I had no idea that this was even possible just a few months ago, and I've used this very same technique with Elixir quite a few times. So in other words, I knew about tail recursion, but I didn't know it deep enough. Now, if you really wanted to show off, you could do this in one line as well. And there it is. Order n time complexity, as we're calling a recursive routine n times, and order 1 space because we don't need the stack to remember the return of our recursive call. Everything the function needs is sent in as an argument. In other words, this is pure code. Something else that you can trot out in the interview.